Hello and welcome. This is a lesson on heating the earth. Get ready to learn. We're going to talk about conduction, convection, and radiation today. Did you know? Energy is the ability to do work or make changes. The sun gives us most of our renewable energy. What doesn't come from the sun comes from nuclear energy. We see only a small part of all energy as visible light. There's a lot going on in the sun. A lot of energy is being spit out into the universe. We only see a little bit of it with our eyes. We can feel it with instruments and other things. Energy can be converted from one form to another, but it can't be created and can't usually be destroyed. Why is this important? Well, if we understanding Earth heating helps us understand weather. So if we know how the sun is heating the earth, we can better understand how the weather is formed. Solar energy is renewable energy. It's been here for millions of years. It's going to be here for millions more. The sun will be here for millions of years. Energy is stored to be released later. We do that in plants and trees. Stores sunlight, makes energy through photosynthesis, and stores that energy as wood that we can burn later. So it's kind of like a battery. Stores the energy. Some radiation is harmful. So we have to understand what's going on so we can not be harmed by all the radiation that's coming from the sun. Here we go. Energy can be converted from one form to another. So we have energy in the wood being released by the fire. If you've ever put your hands up to the fire, you can feel the radiation. If you've held your hands above the fire heats the air and the air heats your hands. And if you've ever taken a poker and put it in the fire heats the end of it and it travels and is conducted along the poker to your hand. So we have conduction. The particles transfer heat by touching. Every part of this has to be connected. Convection, however, energy heats air that then heats something else. So you have the energy in the wood being released by the fire, heating the air, which then heats your hands. Then you have, of course, radiation. The energy is released, and through electromagnetic radiation, reaches your hands. So you have conduction, convection, and radiation. You can convert it. It can't be created. Can't be destroyed. Only converted. Well, heating Earth's surface. Radiation from the sun passes through the atmosphere and heats the earth. Some radiation, some is absorbed, and some is radiated again. We have, it says 48% comes in and is absorbed by the earth. That's why the ground gets warm. And then it is radiated back off. If it hits clouds, it gets bounced back again. If there is no clouds, if it's a clear sky, this is why clear summer nights are cooler than non-clear or cloudy summer nights. Now, we're going to talk about the radiation heat transferred. If you look at the whole spectrum, of course you can't see the whole spectrum. You can only see this little part here between red and violet, purple. If you go shorter than that, look at these. This is the length of the wavelength, 10 to the 20th. That's a 10 with 20 zero, or 1 with 20 zeros behind it. It's tiny, very tiny. Look, here's the size of an atom down here. So these wavelengths are very short, but boy, they have a lot of energy. As they get longer and longer, they have different energy characteristics. We have radio waves out here. We have microwaves, yes, the things that heat your food. We have infrared and ultraviolet. We have infrared on the red side of what we can see and ultraviolet on the right side of what we can see of the violet. The infrared is felt as heat. You might see these in a fast food restaurant to keep food warm. It's under those red lights. Keeps the food warm. Infrared radiation. Now, ultraviolet, it's a major contributor to skin cancer. You see a tanning bed here. Causes tanning. Also causes sunburn. But it's blocked by SPF cream and ultraviolet lens. That's why sunglasses have UV filters on them. SPF cream in your suntan lotion blocks this ultraviolet light. Now, radiation visible light, it's part of the electromagnetic spectrum. Here it is, this little band right here. And of course, they've blown it up here so you can see the different colors and the different sizes of wavelength. Wavelengths of 400 to 725 nanometers. That's 1 times 10 to the minus 9th meter. That's a very, very small. 1 times 10 to the minus 9. It's between the visible light is between ultraviolet and infrared. You have ultraviolet here and infrared there. Then it can be separated with a prism. Take white light, put it in a prism, and here is your spectrum. Red, orange, yellow, green, blue, indigo, and violet. Roy G. Biv. So now we have convection. We had radiation, now we have convection. Indirect transfer energy transferred through a circular motion of a fluid. big words. There's hot water in this pipe, flows into a radiator, comes in, flows through, comes out, and goes back to be heated again. The radiator, this big pipe thing here, heats the air. And the air then, let's draw it. It heats the air, and the air then circulates around the room. It's convection energy transfer. The radiator heats the air that then heats us in a room. Conduction. Heat transfer through direct contact with a source. We've got hot water in here, which is heating the pan, which has a direct source to our hand. Yeah, there's a lot of other things going on here. We've got radiation, we've got convection currents in here, we've got evaporation, but if you can focus on the conduction part of this, the bottom of this pan is hot, and that heat rises up through the pot, through the handle, and into our hand. That's why you need an oven glove or some kind of protection against the conduction. You need to break the conduction so your hand doesn't get burned. Now, temperature affects air density. Higher temperature air is less dense. The molecules are moving around more. They're bouncing into each other more. They need more distance between them. So the air temperature, the higher temperature air is less dense. The hotter the air is, the less dense it is. And conversely, or the other way, cooler air is more dense. Hot air balloons fly due to the density difference of the hot to cool air. If you can fill a bag with hot air, it will rise. The cold air will push down because it's more dense. That's why in the baskets of all these balloons, you'll find a burner. Creates a flame that goes up in the balloon and heats the air, pushing the less dense air out of the balloon and causing the balloon to rise. So why is this important? Understanding Earth heating helps us to understand weather. Solar energy is renewable energy. It's always going to be there, at least in our lifetime. The sun will be there for millions of years. Energy is stored to be released later. We can grow trees that we can then harvest, releasing the energy. Some radiation is harmful. We need to know what that is. There's your lesson on heating Earth.